Okay, now we come to the effect of imperfection. I mean, what are the effects? As you can think about the two or three effects very easily, as I have already given you the example of like the density, the thermal conductivity, and their strength, ductility, brittleness. They all come up with uh, you know uh, imperfections as well. So they all will get compromised if there is a imperfections. Okay. So look here quickly. The first one is mechanical properties. All above example that we have taken that are coming from the mechanical properties. So strengthening the mechanism like the work hardening really on dislocations. Okay. So work hardening process is basically done. Okay. So to remove your dislocation so that your material will get strengthened. So what the kind of the effect is that strength will get compromised. Okay, grain boundaries impair the dislocation motion, increasing the material strength. Okay, so grain boundaries impaired dislocation motion. Dislocation motion, if they have stopped the motion, then it will increase the strength. Okay, now come to the electrical properties that we are not much concerned about here, but still we can see here. So vacancy and interstitial affect the conductivity of the semiconductors. Point defects creates the charge carrier traps. Okay, so that they will basically compromise your electrical conductivity. How? I mean, suppose I mean how the electricity is being uh, transferred. It is a basically movement of electrons from one place to another place. So if the charge which is basically responsible to transmit the electricity that will get trapped in the point defect, right? If there is a vacancy and they will trapped, and if there is not a vacancy, I mean if you have seen in a interstitial kind of the point defects, then here also the charge gets trapped. So if the charges have trapped in that particular point defect, then the movement and will stopped, and that why your electrical property will get compromised. Okay, so diffusion means vacancy and interstitial charge enhance the atomic diffusion. Diffusion means I mean they diffuse. Diffuse I mean they transmit kind of things. Okay, so they will enhance the atomic diffusion. Okay, so vacancies. I mean vacancy means there is a no such atom. They have removed from their point and there is a vacancy. There is a vacant space. Okay. And optical properties, if we talk about the optical properties, then the imperfection causes the changes in the refractive index or the color in material like other. This is the example. Yes. So, what is the refractive index? The refractive index means when the light, light comes to the material, okay, or the surface, and when they pass through the material, they deviate from their own position on line. The way they are following, suppose they are coming from the sunlight, okay, and once they reach the surface of that particular material, and once they are traveling from inside the material, they will deviate from their own way. That is a refractive index, as you have already seen in your water. Once you touch or light up your on the water, the light, you can see this phenomena very easily. Once you impair the light on the water, the light line will deviated, okay, from their straight line, as you can see inside the water. So inside the water they will look like they are deviating from their own straight way. Okay, that is known as the diffractive index. It could deviate more, sometimes it could move less. That depends on the diffractive index of that particular material from which the light is coming through. Okay. So this, I mean, so obviously, if there would be the kind of defect in your material, the defective index will compromise. As you all know that, I mean, suppose there is some kind of a perfect or fixed refractive index of particular material, and if there is a dislocation or imperfection or defects, so then it will deviate either more or less. I mean, they will change their diffractive index. That will the kind of compromise property. Okay.